السلام عليكم ورحمة الله. دكتور سعيد أنور. This subject is about Mathematics 1 for Management. Lecture number 9. Now we will start for chapter 6. Determinants and Matrices. What is the determinant? The determinant is a shape and method to determine the value and arrange this value in rows and columns. A determinant can be determined by its order, and the determinant may be order 2 and order 3. Here for the determinant exists rows and columns. The number of rows must be equal to the number of columns. Determinant of order 2 meaning 2 rows and 2 columns. Here is the first line here is determinant for order 2. First row is A1, B1, the symbols. A1, B1, and all these symbols may be called a number after that. So A1, B1 is first row, A2, B2 is second row. If Y column, A1, A2 is first column, B1, B2 is the second column. How to get the value of the determinant, the value of these numbers? To get the value, we have the diagonal. It's the left diagonal and then the right diagonal. The left diagonal is A1, B2. Second diagonal is B1, A2. Why? Because it has square determinant, 2 by 2. So to solve the determinant, or to get the value of the determinant, we have multiply A1 times B2 minus B1 times A2. Left diagonal minus right diagonal. As an example, a determinant of order 2, the value is 5, negative 2, 3, negative 4. What's the value of the determinant? So multiply 5 times minus 4 minus 2 times 3. So 5 times minus 4 equal minus 20. Minus 2 times 3 is equal plus 6. So 20 plus 6 is equal minus 20 plus 6 is equal minus 14. Don't forget the minus. Second example, we have determinant order 2. First row is minus 1 and 0. Second row is 3 and 2. So what's the value of the determinant? Right diagonal, left diagonal minus right diagonal. Left diagonal is minus 1 times 2 minus right diagonal is 0 times 3. We get the value is minus 2. We use the determinant to solve system of equations. We have equation of two equations, system of two equations. Each equation have x and y, is two variables. Second equation also x and y. To solve this equation by determinant is very easy. It's called the Cramer. First thing, we have to arrangement the equations. How to arrangement? Arrangement in the form ax plus by equal constant. So 3x here, y left. First equation y equals 3x plus 1. Make his arrangement 3x first, y transfer to right, so minus y equal plus 1 transfer to the other side is negative 1. So first equation is 3x minus y equal negative 1. Second equation is arranged already, 4x plus 2y, but we have to move minus 7 from left to right. So the equation 4x plus y equals 7. So we have two equations, we want to solve it. First equation is 3x minus y equal minus 1. Second equation is 4x plus 2y equals 7. To solve by determinant, we have get the determinant of d. What is d? D formed by realizing the coefficient of x and y in the order. So we make a determinant with 2 by 2. First, coefficient of x is 3. Coefficient of y is -1. Second row, coefficient of x is 4. Coefficient of y is 2. And value of the determinant 3 times 2, 6 minus 1 times 4 is 4. So the value of d is 10. So first thing, we have to determine the d. D is the coefficient x, y, and solve it, we get the d. We continue to solve the two equations together. First thing, get d. D is coefficient of x, coefficient of y, coefficient x, coefficient of y, and so get the value of d is equal 10. Second, we get how to get x value. First, we get nx. What means nx? We have the determinant. You know the determinant? The determinant have row for x, row for column for x, and column for y. Nx, omit column of x, put column of the other side, the value of the constant. So we get nx, omit first column, put -1 and 7 is the value of right hand side of the two equations, and the same column deleted, the same second column is the same, and you get the value of get nx. So -1 times 2 minus -1 times 7 is equal 5. So what's x? To get x is equal nx over g. So we have divide nx over g, we get the value of x. Nx is equal 5, g is equal 10, so x is equal 5 over 10, equal half. Now we get y. To get y, first get ny. How to get ny? Omit the second column of g and put the right hand side. So ny is equal 3, -1, 4, 7. Get the value of ny. The value of ny is equal 3 times 7 minus -1 times 4 is equal 25. What is y? Y is equal ny over g. The value of ny is 25. The value of g is 10. So y is equal 5 over 2. So x equal half, y equal 5 over 2. We can check our result by substitution of any of the two equations. Left hand side equal right hand side. We finish determinant of order 2 and know now how to get the value of the determinant. Now determinant of order 3. What's order 3? Meaning 3 rows, 3 columns. 3 rows times 3 columns. We have 9 elements. First row is A1, B1, C1. Second row is A2, B2, C2. Third row is A3, B3, C3. What's A1? Coefficient of x. What's B1? Coefficient of y. What's C1? Right hand side. All this first equation. Second equation. What's A2? Coefficient of x. What's B2? Coefficient of y. What's C2? Right hand side. Second equation. Third equation. A3 coefficient of x, B3 coefficient of y, C3 right hand side of the third equation. How to get the value? We get the value. First one, we get first element is A1 times the matrix minus B1 times the matrix plus C1 times the matrix, and we get this value. We illustrate an example by symbols to show how to solve the system of the three equations. We have system of three equations. We studied before system of two equations and solved by the Cramer's rule by determinant. Now here system of three equations. So we have you to use determinant of order 3. The first equation is a1x plus b1y plus c1z equal g1. Second equation is a2x plus b2y plus c2z equal g2. Third equation a3x plus b3y plus c3z equal g3. A, B, C, all these is a constant, values, numbers. X, Y, Z is the variables. We want to know what's the value of X, value of Y, value of Z. First thing, how to get X? Get X equal nx over G. How is, what is G? This is the determinant of the all coefficient a1, b1, c1, a2, b2, c2, a3, b3, c3, and get the value of the determinant. This is the denominator. So the denominator G here, the denominator of nx over G, denominator for y also G, numerator for G, Z also G. So to get X, nx. So first column of the G, omit and put G1, G2, G3. Get the value. Y. Second column of G, change it to G1, G2, G3 in numerator. To get the value of Z, in Z over G. G, okay, we know that. What in Z? We omit or cancel the column, third column of G, we put G1, G2, G3. X, Y, Z, we get the value. Is they have a condition. What's the condition? The G, the value of G must not equal 0. If it is 0, so it is no solution. So first thing to solve, arrange the equation. Y, X first, Y, Z equal G. Make determinant of G. Determinant G. Coefficient X, coefficient of Y, coefficient Z. To get X, in X over G. What's in X? From G. Instead of the first column, put right hand side. Y. In Y over G. What's in Y? Instead of the column number 2, in G, put right hand side. To get the Z, in Z over G. In Z, omit or cancel third column, put instead them G1, G2, Z, right hand side. We get the value X, Y, Z. What is the determinant? The determinant is a shape and method to determine the value and arrange this value in rows and columns. A determinant can be determined by its order, and the determinant may be order 2 and order 3. Here for the determinant, there is rows and columns. The number of rows must be equal to the number of columns. Determinant of order 2, meaning 2 rows and 2 columns. Here is the first line here is determinant for order 2. First row is A1, B1, the symbols. A1, B1, and all these symbols may be called a number after that. So A1, B1 is first row, A2, B2 is second row. If Y column, A1, A2 is first column, B1, B2 is the second column. How to get the value of the determinant, the value of these numbers? To get the value, we have the diagonal. It's the left diagonal and the right diagonal. The left diagonal is A1, B2. Second diagonal is B1, A2. Why that? Because it has square determinant, 2 by 2. So to solve the determinant, or to get the value of the determinant, we have multiply A1 times B2 minus B1 times A2. Left diagonal minus right diagonal. As an example, a determinant of order 2, the value is 5, negative 2, 3, negative 4. What's the value of the determinant? So multiply 5 times minus 4. To continue our problem. The problem is have system of 3 equations. First thing, get G. G is the denominator. Get the determinant and get the value of the determinant is equal 71. Number 2, we get Nx. What Nx is determined from the term of the diagonal, but it change first row, change first column with the second with the right hand side. So Nx is negative 13, 3, 2, 32, negative 6, 3, 12, negative 4, negative 1. So instead, first column put right hand side. Right hand side first is negative 15, second is 32, third is 12. Get the value. How to get the value? These 3 elements. First element is negative 13. Second element 3 is put negative 3. Third element 2 is put plus 2. So with the value after this element, first element negative 13. Cancel first row with first column. We get negative 6, 3, negative 4, negative 1. We get the right left diagonal minus right diagonal. So 6 plus 12. After that, negative 3. Cancel. First row, second column, we have the matrix 32, 3, 12, negative 1. Get the value, 13, plus 2. The same thing, cancel row with column, we get the value. So get Nx equal negative 142. So what's x? X is equal Nx in numerator, D is denominator. So negative 142 over negative 71 is equal what? X. Over 71, not negative 61, is equal negative 2. Also y, Ny, with the second column of the denominator, cancel, put it right hand side, and with the value is equal negative 355. What's y? Y is equal Ny over G. Ny equal negative 355 over G negative 7 is equal, y is equal negative 355 over 71. 71 is denominator. So y is equal negative 5. It's the same. To get z, what's Nz? Nz, third column, change with right hand side, negative 13, 32, 12. Get the value of Nz is equal 142. To get the value of z, so divide 142 over 71 is equal 12. So value of x is negative 2, value of y negative 5, value of z 2. We can check these values in the equation, so it satisfies left hand side equal right hand side. We'll repeat it again by solved examples. We'll repeat which are talking about the determinant. Now we are determined. We talk determinant second order and determinant third order, or order 2, order 3. And we said that determinant is have to square number of column equal number of rows. First example, solve for x and y by using determinant. First equation is x plus 2y equal negative 4. Second equation is 5x plus 3y equal 1. First thing, again, what is d? D is the denominator. Determine coefficient of x and y, 1, 2, 5, 3. Get the value equal negative 7. Second thing, get nx from g. Instead of first column, put right hand side. and get the value. So negative 4, 2, 1, 3, get the value is negative 14. In y, cancel second column, put with 8 right hand side. So 1, negative 4, 5, 1, and get the value 21. What's x? Equal nx over g. What's y? Ny over g. So it's two equations. So it's very easy than three equations. We continue the solved examples. Example number 2. To show how to get the value of the term of 3 order 3. If the term 2, negative 2, negative 1, 6, 1, negative 1, 4, 3, 5. How to get the value for this? You know, the first row here is 2, negative 2, negative 1. With so 2. Cancel first row with first column. We get the matrix 1, negative 1, 3, 5. Get the value. The value of this matrix times this. This determinant times 2. Negative, negative 2. Also cancel first row with second column. We get the determinant 6, negative 1, 4, 5. That's the value. Share plus negative 1. Cancel first row with third column. We have 6, 1, 4, 3. We get the value here. So the value of this determinant order 3 is equal 70. With the same like problem, another matrix, another determinant 2, 5, 0, 0, 3, 4, negative 5, 3, 6. If I got 0 in the first row, is easy. So 2 times matrix 2 by 2 minus 5 times matrix plus 0, 0 is cancelled. So we can get for each element get the value, and we get the result of this determinant is equal negative 88. Another example, system of three equations x, y, z. We have to solve this by determinant. The example here, by using determinants, 2x plus y equal 2, second equation minus 4y plus z equal 0, third equation 4x plus z equal 6. Solve it. First arrangement. Arrangement for what? Number 1, x. The coefficient of x is 2. The coefficient of y equal 1. What about z? The coefficient of z equals 0 for the first equation. Second equation, coefficient of x is equal 0. Coefficient of y equal negative 4. Coefficient of z equal 1. Third equation, coefficient of x equal 4. Coefficient of y equal 0. Coefficient of z equal 1. So the diagonal, determinant diagonal is equal 2, 1, 0. 0, negative 4, 1. 4, 0, 1. Get the value is equal negative 4. Get an x. Instead, the first column 2, 0, 4, 2, 0, 4. We cancel it or remove it. Put instead them right hand side 2, 0, 6. We get the value for nx. Also in y, instead of second column, change it to right hand side 2, 0, 6. Get the value on y. In z also, for the third column, instead z, put the right hand side 2, 0, 6 and get the value. So x equal nx over g. Nx equal negative 2, g is equal negative 4, equal half. Y equal ny over g. Ny equal negative 4, g equal negative 4, so y equal 1. Z equal nz over g. Nz is equal n is equal negative 16, g is equal negative 4, so the value of z is 4. So x equal half, y equal 1, z equal 4. We can check it to know it is the right answer. What is the determinant? The determinant is a shape and method to determine the value and arrange this value in rows and columns. Any determinant can be determined by its order, and the determinant may be order 2 and order 3. Here for the determinant exists rows and columns. The number of rows must be equal to the number of columns. Determinant of order 2 meaning 2 rows and 2 columns. Here is the first line here is determinant for order 2. First row is A1, B1, the symbols A1, B1, and all these symbols may be called a number after that. So A1, B1 is first row, A2, B2 is the second row. If Y column, A1, A2 is first column, B1, B2 is the second column. How to get the value of the determinant, the value of these numbers? To get the value, we have the diagonal. It's the left diagonal and that's the right diagonal. The left diagonal is A1. A matrix A, we can put A as a symbol. A, the symbol of matrix, capital letters like capital A, capital B, capital C, and so on. So a matrix A is a rectangular. Rectangle have rows and column. Rectangular array. If anyone work in computer, you know what array. Array is the number of elements put in row or put in column. It's called array. So the matrix A is a rectangular array of numbers Aij. A suffix Ij. Speaking about symbols, I is number of rows, J is number of column, Aij. If we put A2, 3, so this element A2, second row, 3, third column. So we can put where is A2, 3, A2, 3, second row, third column is the element A2, 3. So this is the matrix like that, rectangular array. In horizontal is I is row, first row, second row, third row, and so on. Vertical is column, first column, second column, and so on. So any element in the matrix I can locate it. So OA 4, 5, A suffix 4, 5 is 4th row with 5 column. You can get the elements. How to read the dimension? What is the dimension of the matrix? Any matrix have dimension. Dimension is number of row cross number of 5, or number of row cross number of column. Aij, or capital Aij is the dimension. So a dimension is a matrix determined by the number of rows and the number of columns of the matrix. If a matrix has m rows and n columns, we denote A by m cross n. M cross n meaning the dimension of this matrix m cross n. Number of rows m cross number of rows of columns n. Like that. If I say 2 cross 3 or 2 by 3, it's a matrix. What's 2? Number of row 1, 2. What's 3? Number of column 1, 2, 3. You have to have many elements here. It's 6 elements. 3 cross 2 matrix. What 3 is number of rows. So 3 rows, first row, second row, third row. What's 2? 2 is 2 columns, first column, second column. By numbers here. If matrix A equals 23, 16, 10, between each element have distance. What is the dimension of this A? How many rows? 1. So 1. How many columns? 3. So A cross 3. So 8 by 3. For matrix B, capital B, how many elements here in row? 1, 2 row. Only one row. What number of column? 1, 2, 2. So matrix B is 1 cross or by 2. Matrix C, how many row? 1, 2, 3. 3. How many columns is 1? So 3 cross 1. Matrix D, how many rows? 1, 2. How many column? 1. 2 cross 1. Matrix E, how many row? 1. How many column? 1. So the matrix E is 1 cross 1. So first number of rows, second number of columns is the dimension of any matrix. We have to know what the dimension, because we know, if I know the dimension good, I can solve after that what is the problem we see. We illustrate an example by symbols to show how to solve the system of the three equations. We have system of three equations. We studied before system of two equations and solved it by the Cramer's rule by determinant. Now here, system of three equations. So we have you to use determinant of order 3. The first equation is a1x plus b1y plus c1z equal d1. Second equation is a2x plus b2y plus c2z equal d2. Third equation a3x plus b3y plus c3z equal d3. A, B, C, all these is a constant, values, numbers. X, Y, Z is the variables. We want to know what's the value of X, value of Y, value of Z. First thing, how to get X? Get X equal nx over G. How is, what is G? This is the determinant of the all coefficient a1, b1, c1, a2, b2, c2, a3, b3, c3, and get the value of the determinant. This is the denominator. So denominator G here, denominator of nx over G, denominator for y also G, numerator for G, Z also G. So to get X, nx for the property of the matrix, we have to put the matrix in, what's that? No, the difference between determinant and matrix. Determinant between two lines, but matrix is between two brackets, square brackets. How to add the matrix? If I had matrix A and matrix B, number one, to add, so you have to the same dimension. What means the dimension? So matrix A must be, if 2 by 3, so matrix B is 2 by 3. If matrix A is 3 by 4, matrix B is 3 by 4. So first thing, to add, dimension of first matrix equals the dimension of second matrix. How to add? Each element add to the corresponding element in the other matrix. We have two matrices here, 23, 16, 10, 7, 9, 11 is the matrix A. Matrix B, 18, 12, 9, 14, 6, 8, matrix B. How to add? First element here, 23, plus 18, it's 41. Second element is 16, plus 8, 12 is 28. Third, 10 plus 9 is 19. Second row, 7 plus 14, 21. 9 plus 6, the corresponding element of the matrix, is equal 15. 11 plus 8 is equal 19. The other example is the same, but here is the decimal number, no problem. We have first matrix and second matrix. So first matrix 0.6. Second matrix is 2.3, so add 0.6 plus 2.3 is equal to 2.9. 0.4 corresponding is 0.6 plus 0.4 plus 0.6 is 1. Second row, 1 plus 1.8 corresponding element is what? 1.9. 0.9 plus 5.2 corresponding element is 6.1. So to add, same dimension. If I look down in this slide, Matrix A is 1, 2, 7, 2 is 2 by 2. Matrix B is 2 by 1. Can we add? No. Why? Because different dimension. Also, matrix A is 1 by 2. Matrix B is 1 by 3. Can we add? No, because different dimension. So, to add the same dimension, 1 by 2 to add 1 by 2 also. 2 by 2 to add 2 by 2 also. Is the addition. Very, very important. Another example, system of three equations, x, y, z, we have to solve this by determinant. The example here, by using determinants, 2x plus y equal 2, second equation minus 4y plus z equal 0, third equation 4x plus z equal 6. Solve it. First arrangement. Arrangement for what? Number 1, x. The coefficient of x is 2. The coefficient of y equal 1. What about z? The coefficient of z equals 0 for the first equation. Second equation, coefficient of x is equal 0. Coefficient of y equal negative 4. Coefficient of z equal 1. Third equation, coefficient of x equal 4. Coefficient of y equal 0. Coefficient of z equal 1. So the diagonal, determinant diagonal is equal 2, 1, 0. 0, negative 4, 1. 4, 0, 1. Get the value is equal negative 4. Get an x. Instead, the first column 2, 0, 4, 2, 0, 4. We cancel it or remove it. Put instead them right hand side 2, 0, 6. We get the value for nx. Also in y. Instead of second column, change it to right hand side 2, 0, 6. Get the value on y. In z also. For the third column, instead z. But now about subtraction of matrix. It's different between addition. What's difference? With addition, a plus b is the same b plus a. But the matrix here, for subtraction, if a minus b is equal b minus a, no, it's different. We look for the two examples. A minus b is the matrix A 2, 3, 4, 1, 0, 2 minus matrix B negative 2, 1, negative 1, 3, 0, 3. We can add each element with the corresponding to the other. We get the result 4, 2, 5, negative 2, 0, negative 1. A minus B. To get the minus, we have to change all elements here. So 2 minus minus 2 is equal to, and so on. The result is 4, 2, 5, negative 2, 0, negative 1 is A minus B. If I make inverse, B minus A, B first, negative 2, 1, negative 1, 3, 0, 3. Negative A, what's A? 2, 3, 4, 1, 0, 2. What's the result? The result will get it negative 4, negative 2, negative 5, 2, 3, 2, 0, 1. The result. So a plus b is not equal b plus minus a. So subtraction is not commutative, but addition commutative. A plus b is the same b plus a. But here, subtraction a minus b is not equal b minus a. Now we study addition, subtraction. What about multiplication? What's multiplication for what? No, multiplication by a constant number, by a number. Matrix times a number, any scalar number. Like, if I have A, matrix A, 2, 5, negative 7, matrix B, 20, 0, 18, 8, want to compute 3A. What means 3A? Meaning, matrix A times 3. To make a multiplication for the scalar 3 or constant number, we have to multiply each element inside A by 3. So A is 2, 5, negative 7. So times 3, so 2 times 3, 5 times 3, negative 7 times 3. We have the result 6, 15, negative 21 is 3. Also, matrix B, I want to time half. Half, so times each element B. So 20 time half is 10. 0 time half is 0. 18 time half is 9. 8 time half is 4. So multiplication by a number, we have to multiply each element inside the matrix with this number. Now we study the matrix addition, subtraction, multiplication by a constant. Now we have example, collect all of them together. This example, if a matrix A with dimension 2 by 3, the matrix contain 2, negative 3, negative 1, 5, 6, 4. And the matrix B also 2 rows, 3 columns. Content of P, negative 3, 0, 4, 2, negative 1, 5. Show that first one, 5 times 2A, 5 scalar, 2 is a scalar. I prove that 5 times matrix 2A equal 10A. First, 5 is outside the matrix. 2A is matrix A times 2. So 2 times each element in A. So 2 times 2, 4, 2 times negative 3, negative 6, 2 times negative 1, negative 2, 5 times 2, 10, 6 times 2, 12, 4 times 2, 8. After that, all this matrix times 5 for 5 times each element inside the matrix. So we get 20, negative 30, negative 10. So 5 times 4 is equal to 20. 5 times negative 6, negative 30. 5 times negative 2, negative 10. After that, 5 times 10 is 50. 5 times 12 60. 5 times 8 is 40. Is the left hand side. What's right hand side? Can show that. So that it proves that left hand side equal right hand side equal 10A. So the matrix A supposed to multiply by 10. So 10 multiply each element inside A. So 10 times 2, 3, negative 1, 5, 6, 4. So 2 times 10, 20. 2 times negative 3, negative 30. 10 times negative 1, negative 10. 10 times 5, 50. 10 times 6, 60. 10 times 4, 40. It's the same result by with left hand side. Left hand side is the same as right hand side, so it's correct. Question number 2. We want to prove that 4 times 3 total times matrix A equal 3 times matrix A plus B. Take left hand side. 4 times plus 3 is equal 7 times A. So 7 times matrix A. Matrix A 2, negative 3, negative 1, 5, 6, 4. Multiply each element inside the matrix by 7. We get the result 14, negative 21, negative 7, 34, 42, 28 is left hand side. What's right hand side? Prove that 4A plus 3A. So first, 4 matrix A times 4 for the matrix A. Each element in A times 4. What is this result? Plus each element of A plus times 3. Okay, the result. And addition together, we get the same result. So left hand side equal right hand side is question number 2. Question number 3. Prove that 3 times matrix A plus B, and 3 times big addition first, A plus B, make a matrix times 3 in the left hand side. Right hand side is 3A plus 3B. 3 outside. We make addition A plus B, A plus B. Each element in A corresponding to each element of B. So 3 outside the matrix, 2 negative 3, negative 3 plus 0, negative 1 plus 4. Second row, 5 plus 2, 6 minus 1, 4 plus 5. So we get negative 1, negative 3, 3, 7, 5, 9, all times 3. So times 3 for each element inside this matrix. So 3 times negative 1, negative 3, 3 times negative 3, negative 9, 3 times 3 is equal 9. And 3 times 7 is 21, 3 times 5 is 15, 3 times 9 is 29. It is the left hand side. What is the right hand side? 3a plus 3b. We get first 3a. 3 times the matrix A. Each element in A times 3. 3 times b. Each element of b times 3. After multiplication we add. After add together, we get the same result as always the left hand side. Then left hand side equal right hand side. Thank you for this lecture.